We applied these logarithmic and exponential rules in college algebra today to solve these equations. On number 1, you start by putting it in log form. So that would be log base 4 of 15 equals x. And then you need your calculator to finish it out. So on the Inspire, you would press Control 10 to the x. See how log is typed right above that red button right there? Base 4 of 15. And we get 1.95. When you write your answer, please round to at least 2 places to the right of the decimal. One reason, on this one, for example, if you were to round to the nearest whole, that'd be 2. And I think we all agree that 4 squared is not 15. So that's why it's important to not round too much. On number 2, it looks a little different because of that 40. We need to isolate the e. Or another way of thinking about it, get rid of the 40. So we can do that by dividing both sides by 40. And then the e is all by itself, and you can put it in log form. This one's kind of weird because of the e, because at first we write log base e of 6 equals 0.6x. And remember we talked about it last week, log e is the same as natural log. And let's look at why it's important that you realize that, because the Inspire is a little confusing. So let's turn this off, go back to the calculator. If I press Control Log and I type in an E, first of all, I can't type the E from the alphabet down below. It'll give me an error. So if I type this E, it wants an exponent. And it's definitely not 6 because 6 goes up here. And I need that to be just an E, so you would have to know that that needs to be a 1. And if you're good with that, then just type it like that. But remember, log E is the same as ln, so you could press Control ln, and then just a 6, and you get the same exact thing. So that ln button is Control, see where it says E? Right above it, it says ln. And that's it for that one. So 179,176. Equals 0.6x. And then let's solve for x by dividing by 0.6. And we get 2.99. All right, let's try another one. I'm going to scroll up so we have room, mainly for that number 4. Number 4 is not fun. On number 3, I need to isolate the 5, which means I need to get rid of that 3. So I can put this thing in log form. So let's add 3 to both sides. Then we can put it in log form. And go ahead and give it a try from this point. See if you can get to the final answer for x. So last step, divide by 4, and you should get 2.15 approximately. All right, number 4 is rough. I would call this just a bonus problem. And in order to do it, you need to notice that e to the x times e to the x equals e to the 2x. Also, you need to notice that negative 3x minus ex equals negative 4e to the x. And when you see that, and that it's impossible to isolate the x and solve, then hopefully things start to click. Especially this concept right here, because I can factor this. Must factor. So you start with your 2 parentheses. And I can put e to the x in the first spots, because I know if I multiply first times first, I get e to the 2x. The next 2 numbers are very easy. 2 numbers that multiply to 3, add to negative 4. And that's a negative 3 and negative 1. And if you're second guessing that, wondering how it works, we already proved it, because I know that that is negative 3ex. I know that this is negative ex, and when I add the 2 together, I get the middle term. That's the way to check to see if you factored it right. So, now we just need to solve for x. We set each factor equal to 0. Get the e all by itself. Put it in log form. Natural log of 1 is 0. Natural log of 3, I have to type that one in. I get 1.10. All right, once again, that problem, that number 4, I would call that a bonus problem. That is very complex. If you can do 1, 2, and 3, you're good to go. Let's try this word problem. Maybe hit pause and read through it. A question I think that we first need to get around is, what is 17? Is it R or is it X? And I would say it's R. Also, another place people mess up is it says it's given as a percent. That means do not move the decimal of the percent. Keep in percent form. And that means we just need to find x. So let's plug in 17. Let's get rid of the 6 because I need to isolate the e. And we get a repeating decimal of 3. Put it into log form. Which, remember, log e is the same as natural log. and we get 1.0415. Lastly, we're going to divide by 12.77, and we get a blood alcohol concentration of 0.816. If you rounded differently, maybe you got 0.815. That's not a big deal. I went so far out because I felt like 0.8 was a big deal, according to the law, in terms of blood alcohol concentration. So I was interested, was it over? And yes, it is over. All right, see y'all later.